Welcome everybody to our course on Introduction to Mechanical Micromachining. In the last class we started with a discussion of a 3 parameter or the 3 different characteristics, that is accuracy, repeatability and the resolution. And we have seen that if the resolution of one of the components is less, then your whole system cannot be operated to the full extent for which it is specified. So, that was a problem, and again it will create a problem with the accuracy. So, now let us see further in this case that what are the different type of configuration of the machines and which configuration is important for making a micro machining machine. What are the different structural configuration? Mostly here what we are discussing, we are looking at the 3 axis machine only. So, we can see that what are the different way we can identify those axes. So, this is one of the axis where the tool is moving or the axis is moving in this direction, and this is one axis that is called Z axis, and this particular axis is called the X axis, and this particular axis is called the Y axis, correct, and your workpiece is located at this location. So, this is the location of the workpiece. Correct. So, now what are the movement here, that now you can see that only your table does not have any axis here. Your whole thing is mounted on the column, and this particular column has all the 3 movement. Whole column is moving in y axis direction, then at some height you have mounted a x axis, and then this z axis is moving in this direction, correct. So, this is called the fixed bed moving column. So, your bed is fixed, but your column is moving in this direction. Second is the bed type. Here what is given, that 2 axes are in the table. Now, in this case if you can see, there is no axis on the table, but it is a bed type. So, only your z axis which is moving in the, that is the only movable axis on the column, but remaining 2 axes are on the table, right. So, that is called bed type construction. And this is the third time. Here again it is called bed type construction, because still we have one axis moving onto the table or the base, but 2 axes are mounted onto the column. So, this is the one axis, that is Z, and this is the x axis, and your y axis is in the table. So, that is called one axis on the table. Now, this is called bridge type construction. Now, what is here, that your workpiece or the table is fixed right now here at this location, but what happens, that this whole thing is a bridge, and this whole bridge is moving in the y direction, and your tool which is actually on the center of this bridge, and then your z axis is moving up and down in this direction, as well as it is moving in the x direction, in this direction, right. So, here this workpiece, you can also see that this particular thing is independent than the movement of this y axis. So, this construction is also very popular in machine tool. And this one is the gantry type of things. Here what is the thing, that still there is no movement onto the workpiece side. It is almost same here, that you can see that y axis is same as the bridge type thing, but what happens, that in this particular location your tool was your particular bridge was the fixed one. That means, there was no movement on the bridge, but your tool was moving actually on this bridge. So, it was moving in the x direction on this bridge, and then it was moving in the z direction. But here what is happening, that your tool is actually capable to move in the x direction only, but this whole bridge will move in the z direction. So, this is under configuration of the machining structure, and there is still no connection with the all axis with the workpiece. And this is the last one. Here it is called vertical machining center, or it is called the C type construction, that I will show you in the next slide, that it is similar to this type of thing. Set your table is located here and it is moving in this direction and this direction. Your tool is located here, tool is moving in up and down motion, and this whole thing is structured in this way, correct. So, this is the construction of this particular base type, and this tool is located here and your table is again located here. So, table or the workpiece is moving in x and y direction, and your tool is moving only in the z direction, that is on the overhang portion. So, that is why it is called the vertical machining center, or this is called C axis, because here the structure loop is something like this. So, this is called the C. So, that is why it is called a C construction. So, now question is that which particular configuration is good for higher stability, higher stiffness, and whenever there are forces acting onto the tool or the workpieces, at that time it should not deform permanently or the temporarily. So, now let us see that out of the 6 configuration which one is better. Now, which one is better, that this particular thing is the much better, that is this called vertical machining center, or it is called the C axis type of thing. Why it is so? Let us see. So, most popular construction is this CFrame construction or the vertical machining center. This is this one. Why it is so? That here what is the advantage here, that spindle or the Z axis, what it is showing, that it is only moving axis onto this particular part. So, now if you see here, the spindle axis is only moving. In other than this particular setup, if you have seen that earlier slide, many motions were given here and here at this location, but that is not the correct one. So, and rest of all the motion, that means x and y motion, both things are located into the table. So, why it is important here? Because whatever structure you are making, like we know that getting a perpendicularity between the two surfaces, it is extremely difficult, because even if there is a problem in the few microns here and there, that is enough to destroy the component or the operation at the later stage when you are using that particular defective machine for micro machining operation. So, better that whatever moving axis, that it should have minimum amount of movement in different direction. So, this is the configuration where you have only spindle or Z axis which is moving vertically in this particular case, and that is a very big advantage compared to other setups. So, what is the advantage? Advantage is high stiffness and high accuracy, because if your stiffness is very high, we know that your machine tool structure will not deform, and then rest of the things is depending on the encoder and the position movement, whatever we are using, that we have seen in the resolution part, that depends on them, that what you are selecting for that. But because of this high resolution and end up with the high accuracy, and this is the way this structure is very important. But still there is a problem here also, because if you increase the length travel of the Z, now consider that suppose your Z travel is this much, correct, and then this is the remaining parts, and your table is located here, it is moving in these two direction, and this is the base of this machine, correct. So, more this thing, that means more you have to look after the straightness. So, straightness is important, or it is a issue. Straightness of the column Z. So, this is creating a problem, because that means where it is creating problem, that you cannot actually put a workpiece very big here, so that you want to do a drilling, suppose in a 50 millimeter or something, at that time travel will not be that much. So, you have to work within a small movement of the z axis, that means your depth of cut will be sacrificed in this particular case. So, if you are working with a lower z range, low z range, low depth of cuts, because you are going inside the workpiece and that is creating problem. But still we know that we are working, we have to do some machining or something at micro scale, and few microns here and there, it is not a big issue here, but still you have to consider this part very comfortably, because many times what happen, that suppose your tool is located here and we know that it can move from here to here, consider 50 mm. Okay, and this is the base of the table and this is the workpiece you are putting here. So, workpiece has also one height. So, let us name it H, and your tool is located here which will do machining. Okay. So, now what happens, that this is the total range of the travel, Z travel. So, now your tool is right now here, it can move up to this location up to 50 millimeter. Now, consider this is the one location, it is very easy that mounting of this workpiece from this location is very easy, because H is, suppose consider, let us say that this is also 50 mm, and you want to do small machining here, you want to create some features here, micro machining. Machining location. Now, there is another problem. Now, let us see that now we have one more workpiece which has a height little bit high, that is not a 50, but suppose it is 100. Now, it has a 100. So, now we have to put a 100 here. So, that is almost, this is almost double than this, right. So, now why this z axis play important role, because if you have variable height of the workpiece and every time your objective is to do machining here only, same way whatever we are doing in the earlier workpiece, but now height of the workpiece is little bit large. So, to accommodate such type of workpieces, what we need, that we need the adjustment or the long length of the Z travel. So, that is the only reason, but our machining process or the machining depth will be obviously low, but when you are putting a big workpiece or the long height workpiece, at that time it is a issue, but that is not a problem in every time, but sometimes you have to also think about that what are the components you are planning to machine by this particular machine, depending you have to design the Z axis. So, what we need a balance between the tight tolerance and the length of the Z travel, because if you are moving or if you are making a very long Z travel, then at that time there is a high chance of creating a problem in terms of the run out and the axis symmetry. So, we have to make sure that we are getting a tight tolerance also, and there is a reasonable length of the Z travel available, so that maximum number of workpiece with a different height you can machine without any problem. Now, coming to the structural loop. So, what is this structural loop? That for understanding this thing, let us we take one example, that how efficiently and accurately you can cut. Now, there are two person, one is a very young guy and there is one adult who is, both are cutting vegetables here. Now, what is the problem here, that suppose you can understand that if when we are become little bit more aged, at the time where there is a problem in the our structure also, this become little weak bone and joints. Vision is also a problem. How efficiently you can cut with not with but at different edge, correct. So, now you can see that this person is standing, but still it is able to cut, but when we become little bit older, at that time what happens, that our strength and everything decreases and we are not able to cut as efficiently as this one. So, there are problem with the joints and everything. So, same thing is in the machine also, because when the machine is completely new, at that time all the axes and everything works very fine. Whereas the time passes, there are problems in the joints, then you are end up with some of the loose connection in between the joints, which are very difficult to identify unless you do some type of calibration. And there is a aging of the electronics components also available, because everything will not work as fine as at the starting and after 1 year or 2 year. So, everything will create a problem in the structural loop. But right now what we are making by taking this example, what we are discussing about the joints and the bone strength. So, if your bone strength and the joint strength is very stiff or very high, you can actually do very easy cutting in this case. So, same thing is in the machine. So, let us see that how we can correlate this example with the machine. So, what is the structural loop in the joint in the machine? That it contains all the joints, structural element that position the tool with respect to the workpiece. So, now these are the two configurations that we have seen in earlier slide, that this particular thing was the vertical machining center, and we have also understood what is the C construction. So, here this is the C construction, because this particular thing is considered as a C type of thing, and here we have a 2 loop, because this column is taking care of the balancing of the Z axis. So, that is why it is called the structural loop, this thing. So, now where this structural loop starts, because this whole thing is connected, only opening position or the vacant position is the location between the tool and the workpiece, because we know that we have a tool and this tool is actually going from upward, and then we have a workpiece and that is coming from the down, correct. So, now when you are joining these two things, then our loop is completed. This whole thing is fixed, there is no problem in that, but whenever you are joining this thing, joining means we are not joining just stationary, because they are in a dynamic position. There are material removal, lot of forces are acting between the tool and workpiece, then all these particular things should able to absorb those shock and without any permanent or the local deformation. So, our structural loop is contains all these joints and structural element, because this is called structural element. And whatever is this thing, that here we know that this thing is moving up and down. So, this is the joint, and then we know the x travel and y travels is also moving in these different directions, that is also considered as a joint, it is not the fixed one. So, structural loop gives an indication of the machine stiffness and accuracy. Now, consider that if there are some problem in the joint, suppose there are some bolted, because either it is a bolted or it is a fixed by in terms of some type of slots. So, if there is some problem here, what is happening, that it is not exactly moving vertically, but it is moving little bit in this direction or maybe in this direction or maybe in this way, right. So, this we will see that what are the geometric errors. But now, if in this particular case, what happens, that your stiffness is reduced, because whenever you are working with a loose connection and you are giving lot of forces here, this particular loose connection will again propagate the vibration throughout the system, and obviously you are not able to get any machining operation with a high accuracy, and that is the problem with this type of structures. So, these are the two structure. Let us discuss this two structure first. So, this is called open loop structure, because now we have seen earlier two structures. So, this one is open loop, because this whole structure here you are not able to mix or you are not able to fix two things together here. So, this is the location of the workpiece and tool, and so this is called the open loop structure. So, what are the problem with the open loop structure and what are the good things? So, there is a lack of symmetry. So, what happens here? We know these are the two things, and when our open loop structure, that means this particular thing is at this direction, So, which way it is open, that there is a distance between these two and there is a distance between these two also, because our base is located here, your tool is located, workpiece is located, tool is located here, and how much is the distance overhanging part, and what is this particular long length also, vertical length. So, that will be decided by that part, and here problem is that it is not symmetric structure. Symmetric structure, that means that when you do machining, at that time this location is here, but from at this particular location nothing is there, but all the thing is located on the one side, that is on the right hand side. So, if you actually consider this one as a center, if you see from this direction, this is actually equally divided in this whole part. So, consider this is the one part, but if you see from this particular direction, actually this whole thing is overhanging part, right. So, overhanging part is very problematic when you are working with a micro machining or the micron range dimension. So, what is the problem? The long open loop have less stiffness and less accuracy. Long open loop means that suppose this particular thing is little bit extended and this is the thing, now consider. So, this is more extended and your tool is located here. So, whenever you are putting a force here, now you know that it work as a cantilever beam. This one is a fixed one. Now, let us consider a cantilever beam here itself. So, this is the cantilever beam and this is your fixed point and this is your free end, and your cutting tool is attached this location. So, your forces will move in this direction, because you are pushing the workpiece also, workpiece is also resist that particular cutting action, then you are getting a force in this direction. So, whenever you are moving and it has this weight also, its own weight is also, because we have seen in the scaling law that your cantilever beam will deform because of its own weight also, and because of that you are getting one deflection, that is called delta right. So, because of this, what happens, these are called very long open loops, but if it is very small, I think it may not give any so much of problem, but still some machines available which has this type of C structure or the open loop structure, but with a very small amount of open loop. This z axis extension of this z axis bar or this particular column is not so high, so that you can get this thing. Where is the advantage? That it is good for small and the low load machine. That means, when you are machining with a very fine features and some more type of a low load machine, then it is good and you can still use for the micro machining. Then the closed loop structure, this is a closed loop structure. Now, what is the advantage here? Because all the thing again it is a symmetric on both the sides, and your workpiece is located at this particular location. But now, if you see here that these are the two loops which is taking able to separate the whole things from this particular side, and then your Z is moving up and down from this direction and your workpiece is moving in the x and y direction here. And now, considering the support of the Z axis, comparing the earlier slide, you can see that this whole structure is very stiff in this case, and that is the reason the stiffness of this particular closed loop structures are very high compared to the open loop structure. That easy access to the work zone, because now here see that you have a large area here and you can easily access most of the things here, and the strong and rigged structural loop. So, here we have this structural loop, it is very strong, because now it is combined from the both, it is supporting from the both the sides, and this is actually at the center. So, it should not create any problem, and very good thermal stability, because now we know that each and every material has some thermal expansion coefficient. So, if there is a large variation in the temperature, what happens, this because of the symmetric structure, what happens, that your tool will not deviate from the center of the axis, that we have seen in the last, probably in the previous 2-3 lectures, that how the deviation of the tool can be affected by the variation in the temperature. So, symmetric structure are very important for this type of micro machining operation, and you mostly it is used in the macro scale ultra precision machining, and like CMM. CMM is the coordinate measuring machine, because many times what happens, that CMM is coordinate measuring machine. Now, what this machine does, that you put a workpiece here and there is a probe, and this particular probe, now suppose this is the workpiece and this is the probe. So, what this probe does, that probe will touch the surface and every time it will find out what is the coordinate of that particular location. So, if you do not have a CAD drawing or the 3D model of any component, and if you want to generate a 3D component or the 3D drawing out of it, then this probe or this CMM is very useful, that it will get all the information data cloud, and after data cloud what you can do, that you actually join those points in terms of different curve fitting techniques, and you can get the real picture of that thing, and after that you can convert into the different type of drawings or the different type of views. So, that is why it is useful, and this is ultra precision machining, because in ultra precision machining we have seen that different example that we are working with a very small amount of depth of cut, because in ultra precision depth of cut is starting, you can go with the 0.1 micron also, but in micro machining what we do, that we actually go with the little bit small, little bit higher in this, it is a tens of micron, correct. So, this is what is difference here. So, when you are working with a very small depth of cut or the small feature machining, at that time more stability is required. So, ultra precision machines are also very steep in terms of the movement or in terms of the machining characteristics. So, that is very important. So, what are the parameters which affect the structural loop? So, there are many things. The unknown or uncontrollable changes in the structural loop are the primary source of the kinematic error in the machining. So, what is the kinematic error? That means kinematic error means we have three axes, x, y and the z one, and all these axes are perpendicular to each other. These axes are this one is this one, and so this is the y, this is the x and this is the z one. So, kinematic error means if any of these axes are not exactly perpendicular to each other, then it will create a problem in the machining. If it is not straight, then it is a problem. Suppose it has some angle between these two, then it is a problem. Suppose if it is a straight, but it has some problem in the construction of, that means your whole thing is not exactly straight one, but it is a perpendicular between the x and y, but if construction is not good, then it is also kinematic error. So, we will see this thing in detail. So, this is called the structure loop. So, machine structure loop is at the center, and what are things it will affect? There is a machine tool induced vibration, because we know that we have a machining operation going on, lot of force is acting, and we are moving a tool or the workpiece in different direction, to and fro in x direction, y direction, z direction, and everything is connected with the bearings, because your spindle is lot of bearings, fins are available. So, it will create lot of vibrations there, and because of the vibration what happens, that it will directly affect your structural loop. Heat generated by the motor and friction, because if heat is generated, we know the coefficient of thermal expansion, material will expand even if there is a change in 1 degree or 2 degree at a micron level, and that is enough. Structural deflection is there, because if there are lot of overhang portion available, and because of the overhang portion you are end up with the loosening of the structural loop. And this is the desired surface, this is two layers. Then on the other side, hysteresis of the side and the waist, that hysteresis, that means your back legs, that means when you are starting a position, this is considered one location, you are starting a movement at this location, but you are not going in the same direction. At that time it may go, return path is different and going path is different. So, in that case you have a two output at one particular single input, right. So, that is creating problem. So, hysteresis in that particular, ambient vibration, floor acoustic, therefore, that we have seen that under machine is installed side by, which is giving vibration more. that vibration will propagate inside this machine structure and then it will create a problem. Temperature change, ambient temperature, that means even if you control this friction heat, motor vibration, heat generated here, but if you have ambient temperature change, that means variation within that climate where the machine is installed, then again the structure loop will be affected. Coupling, kinematic motion, AB error, flatness, straightness error, that means this is what we are talking, that axis should be perpendicular to each other, and if that is not the case, then you are end up with the some type of structural loop deformation. Kinematic motion, because we know that we have translation also x, y, z direction and rotation around the z direction, that is in 3 axis machine, but if you rotate in other 2 axis, you can again get the more thing. So, these all different parameters will affect where it is affecting point is the contact point between the surface and the tool. So, at that time there are problems associated with this. So, we have to take care about all these things and then only we will make a structure which is a high stiffness, and each change tend to maximize the error between the workpiece and the tool. So, it is not that which parameter is more important here, but all parameters are important. When you are talking about a micro scale machining, you cannot avoid anything here, and that is the way that you have to build a machine in such a way that there should not be any type of problem from the any component, otherwise rest of the component will be also affected by any problem. So, let me finish this lecture here and we will continue this topic further in the next class. Thank you very much.